Hey guys, Mr. Smith here, and we're doing a little review lesson on solving right triangles for sides. Our next unit in the course is trigonometry, and we'll be expanding on a lot of the things you did in your grade 10 course, and a lot of the things we do actually directly relate to having a great mastery of right triangles and SOHCAHTOA. So let's just dive right in. Got a little review lesson for you guys. We're going to solve for sides. A little motivation problem. My friend Ryan, actually my brother-in-law, he's actually millwright, and a simplified, um, um, overly simplified part of his job is to essentially construct machinery equipment for grain mills around Ontario, and his company is responsible for installing things like conveyor belts into grain chutes. So we have a problem like that here. Um, he is installing a conveyor belt to a window that is about 5 meters off the ground. And for some reason, maybe to be up to code or what have you, the angle the belt makes with the ground is 15 degrees. And Ryan needs to know, how long should he make his cuts? How long should the construction materials be? How much does he need in order to construct this belt? So we're kind of looking for the length of this side. And if you just have a quick think on, and you can, throughout this video, you can feel free to pause and unpause if you'd like to just have some time to think. But why can't we just use Pythagorean theorem for this question? It's a side in a right triangle. We learned Pythagorean theorem to help us out with that in grade 9. But the reason is you need two sides to find the third using Pythagorean theorem. Now it's a great tool, Pythagorean theorem, and it's one you should have in your toolbox by now, and we'll certainly whip this out as we go through the course. But we only have the one of the legs in this triangle, 5 meters. We don't know what the other leg is, and we want to know the hypotenuse. So Pythagorean theorem won't work. We need a different tool. And in your grade 10 course, you developed a tool. You would have spent several lessons motivating and looking at these ratios, but you came up with three what we call primary trigonometric ratios: the sine ratio, cosine ratio, tangent ratio. The acronym that you learned to help you remember those three is SOHCAHTOA. And the way it was defined was that in a right angle triangle, the sine of an angle was defined as the opposite side divided by the hypotenuse. The cosine of an angle was the adjacent side divided by the hypotenuse. And the tangent of an angle was defined as the opposite over the adjacent. So let's look at Ryan's problem and how we can use these trig ratios to solve it. So in Ryan's problem, he's got this vertical height of 5 meters. He's got this angle of 15 degrees, and he wants to know x. A big part of using SOHCAHTOA is deciding which side is which. And because we're given that 15-degree angle, that's our reference angle, the 5 meters is the opposite side in this question. It's opposite from the reference angle. X is the hypotenuse. The longest side is always the hypotenuse. It doesn't matter. And so this particular problem, we're going to use the sine ratio. How does it work? Well, we're going to write out the sine ratio. Sine is opposite over hypotenuse, and we're going to plug in what we know. We know the angle theta is 15 degrees. The sine of 15 degrees equals the opposite side is 5, and the hypotenuse we're looking for is x. And that's an equation where we know everything except x. We can solve for x. How you solve for x, it depends on who your teacher was. I like to show this. Think of it as a proportion. Put sine 15, put it over top of 1, and then you just cross multiply to get x by itself. Multiply 1 by 5, and you'll divide by sine 15. So you multiply what's on the diagonal, and then divide by what's left over. So x would equal 5 divided by sine 15. At this point, you're going to be using your calculator. Make sure your calculator is in degree mode and not rad mode. It's not rad. That actually stands for radians. It's a different way of measuring angles. You want degrees. And also make sure it's not in grad mode, which it refers to gradients. It's another way to measure angles. You want degree mode. And yeah, you just literally hammer this into your calculator. 5 divided by sine 15. And you can see on my calculator, can I get that in there? Is it backwards? It shows up for you guys. On my nice display calculator, I just see everything that's going on, and I get about 19.3. About 19.3. So Ryan should cut his materials about 19.3 meters long. Of course, Ryan will, probably keep a lot more accuracy, and this is a very simplified problem of what he actually does. But you can see why these ratios can help us. So this is my way of setting these up. Your way may differ from your grade 10 course. And of course, I showed a lot of work here. You could shave off some steps if you're comfortable. Let's try a couple more. You decide on which trig ratio solves these problems. Try setting it up and solving. At any time, if you want to pause and try these on your own, you can unpause and fast forward when you want to look at the solution. But I'm just going to keep plowing ahead. In this question, we have this 70-degree angle. And even though this side is labeled with a little a, it's actually opposite from the 70 degrees. This is the opposite side. The side across in the right angle is always the hypotenuse. So here we're using the sine ratio again. Start off writing out the sine ratio. Sine is opposite over hypotenuse. And then plug in. Here the sine of 70. This time we don't know the opposite side. It's labeled with an A, and we do know the hypotenuse this time, labeled with 7.5. And now we proceed. This is how I like to think of it. Think of it as a proportion. Stick that over 1, and to get A by itself, you're just multiplying what's on the diagonal. This time it's 7.5 times sine 70 divided by 1, but that's just 7.5 times the sine of 70, which you can slam right into your calculators. 7.5 sine 70. Pretty close to 7. It's like 7.05 centimeters. I'll just put 7.05. I want to be meters, I guess, in this case. All right, let's do a couple more. Again, you can probably do these on your own, but I'm just going to, keep plowing through these. Pause if you need to. The first two required sine. Does this one require sine or something different? Note that reference angle here is 62 degrees. With respect to the 62 degree angle, the side labeled X we're trying to find is the opposite side. The side adjacent to or next to the 62 degree angle is the adjacent side. This question will require us to use the tangent ratio. So we write out the tangent ratio. Tan is opposite over adjacent. And then you plug in. Some of you can probably just plug in as your first step. You don't need to write the ratio out all the time. But for some of you, it might be helpful. So the X is opposite. So here the X is on top. The 10.2 is the adjacent on the bottom. And what you may have noticed in your grade 10 course, what you may have noticed already now, is that when what you're solving for is at the top in the numerator, you wind up using multiplication. So here we're doing 10.2 times the tangent of 62 degrees, and this will give us that unknown side X. 10.2 times tan 62. I got approximately 19.2 kilometers. Okay. So 3 examples in the books. We're going to do a few more together, maybe with an application focus, talk about what it means to solve a triangle. But let's continue. And as usual, guys, if you want to just plow ahead on your own, you can feel more than welcome to. This time, Ryan's back, and his new conveyor belt has a limit on how steep it can be. The belt is 20 meters long this time. And to be up to code, the angle has to be at most 7 degrees on the ground. How high up the silo should the belt be attached? This time we are looking for this vertical side. So have a little think. Which ratio should you use? Can you guys set up the problem and solve? Hopefully you've given that a go. I'm going to play catch up now. I can see with respect to that 7-degree angle, we are looking for the opposite side. We have been given the hypotenuse, and so we will be again using the sine ratio. I'm okay if you plug in right away, but again, many of you will want to write that out. The sine of 7 degrees equals x over the hypotenuse is 20. And again, you can use a shortcut. Since x is on top, we're going to be multiplying, or you can keep thinking of it as a proportion and use cross multiplication. But 20 times the sine of 7 degrees, I don't think that's going to be too high. Just don't anticipate that being more than a couple of meters. 20 times sine 7. Okay, it's about 2.4 meters. About 2.4 meters. And again, if Ryan wanted to be very precise, he would keep more accuracy. But the belt should be attached about 2.4 meters above ground. All right, so we've mixed up the ratios. I guess none of these require the cosine ratio, but that's okay. We talked about how to choose appropriate ratio, reviewed the skills for solving those ratios. Now let's just talk about some different applications that you would have done in your grade 10 course before wrapping up this lesson. So on occasion, you may be asked to solve a triangle to practice your skills. That just means you figure out everything about the triangle, all the sides and all the angles. So here I've posed a triangle to you, triangle ABC. I've told you that angle C is 90 degrees, and I've given you some information. So don't worry about drawing a super accurate diagram, just draw it out. So C is here. I'll just call that A and that B, and then fill in what you know. Again, don't worry about the diagram. Make a rough diagram. As long as you have the right angle there, it's all good. B is 34 degrees, so that actually does make sense the way I drew my triangle. It's kind of a pretty tiny angle. And AB is 5 centimeters. And now I know, I can see, hey, this is the hypotenuse, right? So we're going to solve this triangle. And again, to solve it means to find out everything about this triangle. And there's a lot of ways you can go about it. You don't need a complex math tool to find the angle at A. You can find the angle at A by using the fact that angles add to 180. You can then find either side using SOHCAHTOA. And I think to make sure we get the cosine ratio in here, I'm going to find that side. And then lastly, we can find the third side using your favorite trig tool. But let's go about how this would go. So for step one, I can say that angle A, since all the angles have to add to 180, then angle A should be 180 minus 90 minus 34. Whatever's left is what's for angle A. And that's 56 degrees. So angle A, 56 degrees, we've got that. Now we need all the sides. Don't get bogged down by choice. Like you have to choose, you have options here. We could have found side AC first, or we could find side BC. I just chose BC. So let's get after it. So side BC is adjacent to 34 degrees. So I'm going to use the cosine of angle 34 degrees. That equals the adjacent side, AB, over the hypotenuse, 5. If you need to write out cosine theta equals adjacent over hypotenuse beforehand, just do that, okay? It's okay. We can see that what we're solving for is on top, so we'll be using multiplication. AB is simply 5 times the cosine of 34, whatever that is, 5 cosine 34. Let's call that about 4.1 meters, centimeters in this case, excuse me. Now you have a choice. We have to find that third side. I might just toss in here, this is 4.1. You can use SOHCAHTOA again. If you like using SOHCAHTOA, that's fine. It works. But why don't we mix in, if you have two sides in a right angle triangle, you can always find the third. Let's mix in Pythagorean theorem. All right, guys, so let's set this up. We're finding one of the legs. side AC is a leg, so we'll be using the version of Pythagorean theorem where we use subtraction. We'll take the hypotenuse squared, subtract the other leg squared, and you can do this in a single step if you want to, or you can do it in multiple steps. I think I'll do it in a single step. So 5 squared is 25 minus 4.1 squared, then the square root. So I got about 2.9 centimeters. Just be advised, guys, if you're solving a triangle, there are often several different strategies. You just got to pick one and go for it. Don't get bogged down by choice. Okay, so we've reviewed using SOHCAHTOA to find sides. We've reviewed what it means to solve a triangle and have done that. Let's do one more. If you want to pause the video and try this on your own, feel free to. But in your grade 10 course, you were introduced to the idea of an angle of elevation, the angle from your horizontal line of sight up to something, and an angle of depression, which is the angle from the horizontal line of sight down to something. So in our question, we have Mario, and he's up in a truck, and the basket's been lifted up in the air. We don't exactly know how high he is up in the air, but we do know he's 40 meters from the tower. And the angle of elevation and depression we've labeled in our diagram there. And we want to find out how high the tower is. So our strategy for these double triangle questions, you would have seen this strategy last year. Often we can break the problem up into two different triangles. So if we look at the upper triangle with the angle of elevation, we know that Mario's 40 meters from the tower, and we're interested in how that vertical side, I'll call that X. And we have a second triangle on the bottom with the angle of depression. Again, Mario is 40 meters from the tower horizontally, and I'm going to call this side Y. And if we want to know the height of the tower, we could just find the individual heights in both of these triangles and add them together, which is what we're going to do. And you'll notice that in each question, we have the adjacent side 40, and we're looking for the opposite side. So we're going to use tan both times. Again, if you like writing out the actual ratio, tan is opposite over adjacent, please continue to do that, but I'm okay if you plug in right away. So tan of 42 is opposite, which would be X, over 40, the adjacent side. As we've talked about, what we were solving for is on top. We're using multiplication, 40 times the tan of 42 degrees, and I'll calculate that in a second. For a second triangle, very similar, the tan of 32 degrees equals the opposite side, which is Y, over the adjacent side, which is 40. And that will mean Y is equal to 40 times the tan of 32 degrees. We'll get that. And then we'll make a concluding statement. We'll add them up. So let's do it. 40 times tan 42, pretty near 36 meters. And a reminder too, if you want time to just try on your own, just pause the video and work through it. 40 times the tan of 32, pretty near 25 meters. And now we can wrap this up. The height of the tower is 36 meters, that was X, plus 25 meters, that was Y, equals 61 meters. So after your grade 10 course, not only would you be expected to find sides in a right angle triangle, but you would also be able to solve a triangle, create a strategy, and also to solve a double triangle problem using SOHCAHTOA. I have attached in the package you got today some practice that you can work on. Of course, you can continue to review for your test Wednesday. That would be tomorrow as you're watching this. You can also proceed to the second video lesson where we review how to find angles, and there's also practice with that. All right, hope you're having a good day, guys. Stay well. We'll see you soon.